All right, this is the video that goes with lesson 8.1. This is quadratic modeling. But first of all, we're going to start off with linear modeling. So basically, if we've got a list of coordinates, when we plot them, they're either going to make a straight line, which is what we saw in the previous module, or they're probably going to make a curve shape, kind of like that parabola, that U shape that we talked about in the last unit as well. So when we type in questions in, basically, we're just going to create a table of values, and we're going to enter those into Desmos. And the important rule is this rule here. When we're doing a straight line, we do Y1 cedilla. That's the key that's above the tab button, or you can use the Desmos keyboard to do that as well. MX1 plus B. So I'm going to move on to slide 2, and you can see I actually already created this. Now, the way I created this table is I clicked on plus, I click on table, and then it lets me type in the coordinates. Now this says x2 and y2 because I already used x1 and y1, so I'm just going to delete that, and we type that in. Now the reason I think this one kind of looks like a straight line. I can kind of see as we go further to the right, it looks like this graph goes up. So the formula for this then was y1. Let me show you on the keyboard where that cedilla symbol is as well. Thought it was down here. I guess I'm not seeing it as well. Let me have a look, see if I can see it. Don't see it there. Don't see it there. Don't see it there. I guess I forgot where it is then. I thought it was on here somewhere. Never mind. All right, so I'm going to press Shift and that button above the tab, and it'll draw that symbol for me. MX1 plus B. And the two numbers that it gives you on the bottom here, this is the equation of the line. So the m is the number of x's. So this is really like y equals 11.5. I'm just going to round a little bit, plus, and that's basically 202, or it's closer to 202 than 201. And notice that as I switch this line off and on, basically that's what this line is. This is called that line of best fit. And you can see we've got some points slightly above, some points slightly below, but it kind of averages out. Some that actually go through the line and so on. Now, specifically for the warm-up question, it asks, use the model to find the number of calories that a sandwich has when a sandwich contains 15 grams of fat. So we're looking at the x values. This is x and this is y. So in other words, for this question, x equals 15. So if I actually type in, and I'm actually going to delete that equation now because we can see the line there already. If I type in x equals 15, and we can actually go ahead and look on the graph, where did this line and this line intersect? And this will actually be our answer. So this number here, this 374, that would be our prediction for the amount of grams of fat in that particular sandwich. Now, as we move on, and actually I had it already pre-prepared here for when I actually teach this in class. So we can have things that create straight lines, and we can have things where clearly we can't draw a straight line here because that wouldn't work for this or here. So sometimes we use curves as well. Both of these are actually called curves of best fit, but we specifically refer to this one as a line of best fit. And yeah, so the data can either be linear or quadratic, which is what that U shape is. And that's going to be the main difference between what we did previously and what we're going to do in this unit here. So sometimes you kind of just have to look at the picture. Like you can kind of see this one's going upwards again. So this one kind of looks like a straight line. This one, it starts to go down, but notice it comes back up again. So this is more like that U shape. So that would be your example of a quadratic equation. We have a little assignment here. Examine the following graphs. Select those that you think are quadratic. Well, that one just seems to go downwards. So I'm going to say no to that one. Oh, you can see this one is curving. And actually, as I select it, you can see that it changes as well. I'm not sure this is giving me the option to select this. Now it's curving, but it's going up and then it's coming back down again. So this is not really a U shape. This would actually be one that's closer to x cubed, but you'll see that one in algebra 2. There's a U shape. That one looks pretty good. That one looks like it just goes straight up. So I'm going to say no to that one. And it kind of goes up, but it doesn't look like it comes back down again. So I'm going to ignore that one there. I'm going to select those two there. I think they're the ones that are most like the U shape, or it can be an upside down U shape as well. So when we're doing this, instead of typing the Y1 cedilla MX1 plus B, and like we did previously, this is the formula we're going to type for every single question when we think that it's actually a curve or when we think this is modeled by a quadratic function. And the reason we use this one is there's some number x squared, some number x, and then just some number. So that's why we have the x1 squared and the bx, because of the x and the x squared. And we're going to try and figure out what these numbers are, the a, b, and c. What are the numbers that, or the coefficients that apply to each of these questions? So looks like we've already got a table typed in here. So once we have our coordinates, same as before, we're just going to create a table. You're just going to click on plus, click on a table, and then type it in. Make sure it says x1 and y1 at the top. If it doesn't, I would actually x out and then just start again and retype all these ones. So as we're typing in then y1, the 1 automatically becomes lowercase, as that's the deal thing, ax. So I put the 1 and then I type in the squared. And you can already see it's starting to draw a quadratic here to match this picture. Plus bx1 plus c. And look at that. You can see that's pretty good. There's a lot of points that go through. A few of these just a little bit away, but that's pretty good. So the equation then for this, the a is the number of x squareds. So this is pretty close then to 0.3 x squared. Sorry, negative 0.3 x squared. The b is negative 1.57 if we round, because the next number is over 5x. And the c on the end is 2.9, so I'm going to put 2.9. Because you can type in the whole equation. Notice I didn't type in every number. I kind of rounded a little bit, but look how close my answer is to the original answer. In fact, my normal rule for these is I normally go to 2 decimal places. So let me put 2.90 for this. I think if you go to 2 decimal places, that's probably going to be accurate enough. And for this first section, that's all we're looking at. We're just trying to find an equation. When we get to 8.2, we'll try and make a prediction based upon that equation. So we're looking at example 2. Use the calculator on the next slide to find the curve of best fit for the data that you see here, and then use that equation. So I kind of created a table here, and you could practice yourself. I believe I actually have, does it say exactly which one this is? Let me have a look. Oh, I can't see. That's not very helpful. Just give me a second to go back and check which one it is. Yeah, negative 110 is the data values that I'm looking for. So it's this one here. So as you type in the equation again, once again, just check the picture just to make sure. You can kind of see the values are going up, but then they're coming down again. That's why we think this is quadratic. And you can see the numbers at the bottom here. So it would be negative 3.19 x squared plus 12.85 or 86 even x plus 5.22. Go back to the original one. Same thing. Use the calculator on the next slide to find the curve of best fit. So it's asking, remind us to use the squared thing. Not always obvious from a table that it is a squared. And you just have to type in the data values that you can see there. Now, I think I actually have these ones already prepared. There we go. 1, 2, 6, and 12. So 1, 2, 6. So we can kind of see then as we type in the squared or the rule that we think, you can see that nice curve shape. And actually, this is perfect. This actually goes through every single point. One of the little clues, not that we need to know this at this stage, if you ever see r squared equals 1, then it means it's a perfect fit. Most of them are actually going to be smaller than 1 because they're not exact. And then as you're reading the answer, 0.93 x squared or 0.94 x squared minus 0.61x minus 0.54. So you just replace each of the letters here with the numbers that you actually see. Let me keep going. This will actually be our last one we're going to look at. This time, they've actually given us a picture, but we can fill in the table. So as we're trying to do our coordinates here, this goes across negative 4 on the x, and you can see that it's level with 5 on the y. So this would be negative 4 and 5. So sometimes you have to create your own table. This point here, I can see it goes 2 to the left and 7 up. So negative 2 and 7. This would be 0, 7. Oh, sorry, that's 6 there. I apologize. That's negative 2, 6. This is 0, 7. And this point here, 2 to the right and 6 up. So that would be 2, 6. And this point here, 4 across and 2 up. So this would be 4 and 2. And it tells us we're going to use a curve of best fit. But you can kind of see that here. You can kind of see that upside down U shape for this question. Now, I believe I actually have this one already typed in. There we go. So I had the values typed in. I typed in my formula, and we can see A is negative 0.21x squared minus 0.3x plus 6.91. We can match that up with any multiple choice question that we have. This one perhaps not quite as good as some of the other ones. This point here is a little further away from the line, and this one's not perfect as well. I notice that R squared value is a little bit less than 1. Not that we need to really focus on that at this point. One thing we should focus on, though, is, and get used to the idea of, graphs that do this upside down u are going to be a negative x squared, which you can see here. Whereas if we have a graph that goes the other way like this, notice the number of x squareds is positive. And that's kind of a good little tool to help you identify which is the correct graph. Is it positive x squared or is it negative x squared? And that's going to do it for part 1 of this clip, but there's certainly a second part to lesson 8.1.